Hello everyone. In this lecture we will discuss about a problem related to the chemical reaction engineering. So the problem is for an elementary reaction A plus B gives product. So there is an elementary reaction in which reactant A and reactant B are combined with each other and producing product P. The reaction rate at 500 Kelvin is 10 times that of 400 Kelvin. So the reaction rate at 500 Kelvin is 10 times higher than the reaction rate at 400 Kelvin. Now the question is, what is the activation energy for this reaction? So activation energy is unknown to us. Now this is the elementary reaction. A plus B gives the product P. For elementary reaction, which is reaction number 1, the rate equation is minus Ra is equal to Kca into Cb, where K is the reaction rate constant. So K is the rate constant, C is the concentration of component A, Cb is the concentration of this component B. Now K is the rate constant, and the rate constant and activation energy are related by the Arrhenius equation or the Arrhenius law. The Arrhenius law say that the rate constant is equal to K naught and to e to the power minus e divided by RT, where E is the activation energy, R is the universal gas constant, T is the temperature at which we can obtain the rate constant, and this K naught is the pre-exponential factor. So this is also the collision factor, which shows that the collision among the molecule or atoms in a reaction. So K is equal to K naught and to E to the power minus E divided by RT. This is the Arrhenius law. Now at 400 Kelvin, the rate constant is given by K1. So at 400 Kelvin, the rate constant is K1, and K1 is equal to K naught and to e to the power minus e divided by RT1. Now this T1 is 400 Kelvin. T1 is 400 Kelvin and T2 is the final temperature or the temperature of the second reaction. So at higher temperature, so this is the 500 Kelvin. Now similarly at 500 Kelvin, the rate constant is denoted by K2, because the rate constant depend on the temperature, also depend on the activation energy. So the rate constant at 500 Kelvin is K2, and the K2 is equal to this one, e to the power minus e divided by R and 2 T2. Now the rate equation, the rate law for the reaction A plus B at 400 Kelvin is this, can be written as this, minus Ra1 is equal to K1 into Ca into Cb. This K1 is the rate constant at 400 Kelvin. Similarly at 500 Kelvin, the rate law for reaction is this one. So for this reaction at 500 Kelvin, the rate law, the rate equation for this reaction is given by this relation. Now divide this relation 1. Now divide relation number 2. This is, suppose this is relation number B and this is relation number A. Now divide relation number A, now relation number A divide relation number B by relation number A. So it is written as minus Ra2. So relation number 2, rate for rate at 500 Kelvin, and this is the rate at 400 Kelvin. So minus Ra2 divided by minus Ra1 is equal to K 2 Ca into Cb, K1 Ca Cb, because rate is Ra2 is equal to K2 Ca into Cb divided by this one. Now this K2 is now this K2 can be obtained from the Arrhenius law, and from Arrhenius law this K2 is equal to K naught and to e to the power minus e divided by R and 2 T2, and Ca Cb here cancel with each other, and the K1 is nothing but K naught and to this relation. So similarly K2 is obtained is equal to this one. Now we can, so this is the K2 divided by K1. We can further simplify this relation, we can further simplify this relation, and we can obtain that K2 divided by K1 is equal to E to the power E by R and to 1 divided by temperature T1 minus 1 divided by T2. Now in this relation, this cancel with this one, K2 divided by K1, and this is already obtained. Now we can further simplify this one, so T2 minus T1, and this is T1 into T2. Now at 500 Kelvin, the rate of equation is Ra2, and this at 500 Kelvin, it is given that the rate of reaction at 500 Kelvin is 10 times that of reaction rate at 400 Kelvin. So reaction rate at 500 Kelvin is 10 times higher than that at 400 Kelvin. So Ra2 is equal to 10 times Ra1. So in place of Ra2 we will written this one, because this is equal to this one, divided by Ra1, this cancel with this one, so this is only 10 is equal to this one, 500 minus 400, this is equal to 100, and when we multiply this, now this is 10 is equal to this one. We can further simplify it. Now after that, apply natural log on both sides of this equation. So ln 10 is equal to E by R into 1 divided by 2000. Now this ln 10 is equal to 2.30, round about 2.30, and this is R, which is the universal gas constant, and this is the 2000, this one, and the unit of the activation energy is joule per mole into per mole, and this is the activation energy. Now this one is the rate constant unit, and this is the 2000, and it is multiplied by 2.30 because it is equal to ln of 2. So ln of 2 multiplied by universal gas constant multiplied by 2000 into joule per mole, because the unit of activation energy is this one. So when we multiply these three, we will get this one, 38,244 joule per mole. In kilojoule, 1 kilojoule is equal to 1000 joule, so it divided it by 1000, we will get 38.244 kilojoule per mole. The activation energy at 500 Kelvin. So at 500 Kelvin, the activation energy for reaction A plus B is 38.244 kilojoule per mole. So the activation energy for this reaction A plus B for this reaction at 500 Kelvin is 38.244 kilojoule per mole. So this was just a little problem related to the activation energy and rate constant and Arrhenius law. Thank you very much for your attention. If you are new to my channel, please like and subscribe. In coming lecture, we will also discuss some other problems related to chemical reaction engineering. Thank you very much.